All right, so this is almost like the last example. Only difference is we have to simplify a little first. So I'm going to distribute this 5. That's 12x, that's 5x, and a minus 15. The minus sign goes to both, and that equals 2x minus 5. I'm going to combine like terms. This is negative 5x minus 3 equals 2x minus 5. Now I'm going to try to gather all the x's on one side. Let's say I add 5x to each side. So I have negative 3 equals 7x minus 5. Let's say I add 5 to each side. It doesn't really matter what side you gather the x's on, just that you gather them all together. So this is a 2 equals, 7x. And then I can divide both sides by 7 and get 2/7 is the only value of x that'll work. So that's how we're going to solve linear equations. Now, these can get a little trickier. On the final, they're going to throw something at you like this. 3 over x minus 1/3 equals 1/6. Now, this doesn't look like a linear equation, but it is. The secret is, to even subtract 1/3 from x, I would need a common denominator. As a matter of fact, I might as well get a common denominator for all 3 of these fractions so I can compare them directly. Just compare the numerators. Least common denominator, what's a multiple of x and 3 and 6? Well, 6 is a multiple of 3, so we don't really have to worry about the 3 now, do we? 6x will take care of us, right? So this is our least common denominator. It's going to be 6x. So I'll do a 6 over 6 here. I'll do a 2x over 2x here. And I'll do x over x here. That'll leave you with 6x down below in all 3 cases. So this fraction is 18 over 6x. This is 2x over 6x. And this is x over 6x. Make sense? Now, if these fractions are equal, then the numerator's got to be equal because all the denominators is the same. So what I know is 18 minus 2x equals x. So now this is a lot simpler. Now it's finally looking like a linear equation. I'm going to add 2x to each side. So I'll have 18 equals 3x. Divide both sides by 3, so 6 is the value of x. So that's how we solve a linear equation. Let's do one more. Let's say I know that 3x over x minus 1 plus 2 equals 3 over x minus 1. Now, I'm going to solve this. I want a common denominator. Well, all I need to do to get a common denominator is multiply this 2 by x minus 1 over x minus 1, and I got it, right? Because that's 3x over x minus 1 plus, got to distribute 2x minus 2, right? Over x minus 1, I'm multiplying that 2 into the numerator. That's where I'm getting this 2x minus 2. That equals 3 over x minus 1. Okay, well, if these fractions are all the same, I can just go ahead and compare the numerators. 3x plus 2x minus 2 equals 3. So combine like terms, 5x minus 2 equals 3. Add a 2 to each side. 5x equals 5. Divide by 5, and x equals 1. Now you might think that we're ready to be done, but one problem. X equals 1 is perfectly good as a solution to this equation. 3 1s plus 2 1s is 5, minus 2 is 3. Now that really does equal 3, so that works. But if I go back a step further, this says 3 1s over 1 minus 1 plus 2 equals 3 over 1 minus 1. What's the problem with that? We cannot divide by 0. No good. So this isn't a real solution because it would cause us to divide by 0. Anytime you started with a fraction, it's probably a good idea to check. I didn't check up here because, well, the only thing that makes the denominator 0 is 0. That's not 6, so this is really going to work. 3/6 minus 1/3. That leaves us with 1/6 now, doesn't it? But down here, we have a problem. Since the only solution we found would actually make us divide by 0, there is no solution. Probably a good idea to check that. In other words, anytime when I said the denominators don't matter anymore, another way to think of that is I was multiplying both sides by x minus 1. That would cancel out all of my denominators. X minus 1 could be 0. Anytime you multiply by something that could be 0, there's a chance that you're introducing, you can go from a false equation to a true one by multiplying by 0. So there's a chance you're introducing what's called a extraneous solution. So anytime you multiply by something that could be 0, like an x minus 1, you have to go back and check that your solution is real. All right. Oh, Lord. I hear a thunderstorm. Please, 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 the power don't go out tonight. Went out twice last night. Oh, I just want to get this unit done, eh? Go to bed. So, tell you what, let's make a third part to this series, save our progress so far. Next, we're going to talk about lines. Bear with me.